Hello, everybody. So today we are gonna do some stuff on how you can do application monitoring using RabbitMQ and OpenTelemetry. So generally, messaging brokers are very important on doing, and you want to monitor your messaging brokers. Some such examples are Kafka, RabbitMQ, SQS, things like that, right? So today we'll just take a simple example of how you can monitor RabbitMQ, get both metrics from the RabbitMQ server, but also how track them across traces and see how they perform, right? So that's what primarily I will do today, and let's see how it goes. So here I have a setup where I have a simple code setup. So I have a machine where I have set up RabbitMQ server, and then I've written a couple of codes in Node.js. So let's see. So we have two applications. One is RabbitMQ receiver, and the other is RabbitMQ server. Sender. Yeah. So these are two applications I have, and then I'll quickly show you how that is structured. So basically, I used ChatGPT to create an example server. So there's a consumer. So I've created two applications basically. So one application, it's an Express.js application. It's doing nothing but just creating a service where yeah, let me find the right command here. So it's just creating a service. Yeah, I think this is it. No. So I think I first created a function, but then realized I need to call through an API call. So yeah, this is it. So there's a sender function, sender application, which does nothing but listens to a port, which I think is 3000. And then whenever a connect request comes, it connects to the RabbitMQ server and then creates a queue and sends that message to that queue. And the name of the queue is hello. So very plain vanilla, there's a send endpoint which will call and it will send a message to this server, right? So this is a SigNoz library, and then we have a receiver application which just listens to the port 3001, and whenever it receives that, it says that hey, the message is received. And basically the sender is the producer and the receive function is the consumer, right? So this is a quick application I have, and then let me take you to the setup here. So yeah, so this is the application we have which you want to run, and similarly there's a sender application. So let me just clear. So I have written that sender.js application here. What we'll try to do today is to monitor these applications using OpenTelemetry collector, and we'll also will instrument both these applications. And what it will do is it will automatically instrument the RabbitMQ libraries also, and then we'll also install a OpenTelemetry receiver for RabbitMQ. So RabbitMQ receiver, and then that will help us collect metrics from that. So that's what we are gonna do today. I will quickly share you how first we'll just do we'll just do we'll just do instrument the Node.js applications and then see the traces there, and then instrument add the RabbitMQ receiver also, and then be able to send data there, right? So let's see. So we'll try to do this through SigNoz, but you can essentially use this any OpenTelemetry supported backend to do this. So we'll go to application monitor and then we'll choose. So I've already done this one side, but just to share with everybody, we will just choose an Express.js framework. And then what we'll do is, so I'm running it in a single machine. What we'll do is, so there are two ways you can send data from OpenTelemetry to a backend server. Either you can just use the OpenTelemetry SDK and then send data to the backend, or you can install OTel collector locally, send data to that OTel collector, and then that OTel collector sends to the observability backend, which is SigNoz here, right? In this scenario, we'll use the OpenTelemetry collector approach because we also want to install OpenTelemetry receiver for RabbitMQ, and that will be just simple. But if you just want to do traces, you can as well install and then send trace data directly to this, right? So it gives you a bunch of steps on like how to run OpenTelemetry as an agent. You can create a file here. I have already done this step. So as you can see, let's see. As you can see, I already have a folder called OTel contrib. I'll just show you the content for that. So you have config ML, and then you can run all these commands there. So yeah, so I have done all the setup. I've set up a SigNoz Cloud account, and I'm sending data to a SigNoz Cloud account. We have the access tokens here, etc. And then if you just go to the next step, what this does is this gives you instructions on how to instrument the OpenTelemetry package. As you see here, it has a auto instrumentation package. What that does, it automatically instruments all relevant libraries. So RabbitMQ is one such library, and that will automatically get instrumented, and you don't need to do anything specifically for RabbitMQ, right? So yeah, this is all the things I've done. So what we'll do now is to just kill my OTel collector first, because I think I have this running already. So I'll kill this first, and then I'll set it up again, right? So we'll get this OTel collector set up. And just to confirm, we have this running. Yeah, so we have an OTel collector set up. It's outputting log files here. If you want to see what are the log files currently which are coming up, let's see. So you can see. So you can see all the data is coming up. I think this you can ignore. This is not a relevant issue. This, yeah, but most of the things are running fine. So we are good here. So we have a OpenTelemetry collector set up here now. And what we have to do is to create like the one instrumentation application app. So I'll just talk about it here. So basically, you have to create a tracing.js file, and that will have all code to instrument your application you want. And as you can see, it imports all the required libraries, and then you have to run this application using this step, right? So that's what we'll do now. We'll just go to our receivers function, and here I have two files. One is tracing hotel collector.js. So this is the exact file which we have copied from here. So, and just to show you what is the receiver function. So as you can see, this is not doing anything, just starting a consumer here, and then it will just wait for anything on 3001 port, right? So what we'll do is we'll run this command here. So node -r dot by tracing. So here I have two versions of tracing. This is like for directly sending data to SigNoz Cloud, and this is for like going via hotel collector, because as I mentioned earlier, we'll be using RabbitMQ receiver also to set this up. So we will we will, um, we will use the hotel collector route. So, and my file here is, the application is receive.js. So this should get started, and as you can see, this is now listening on the localhost 3001 port, right? And now we'll go to the sender application. So similar steps, we'll do node -r. So this also has, just to show you, this also has the same hotel collector JS. The only difference between this and the previous file is that this function is different, and then the service name is different, and that's about it. And then we'll run this again using node -r and send.js. So we also now have a producer function ready, which is listening to localhost 3001. And what we'll do next is, because we have an hotel collector ready, already running here, what we'll do is I've just written a script which uses call to send request to the port 3000. So let me just show you that. So what this does is this like generates, let's say, let's just do 1000 request. In 60 seconds. Or let's just do 30 seconds, right? Because you have to wait for that duration. And this just sends this message, hello RabbitMQ, to this endpoint, right? Where our RabbitMQ sender function is listening to. So what we'll do is we'll just listen to it here, and I'll just run this command. So this will start sending those messages, producing those messages, and it will be starting calling to the sender function. As you can see, the sender function is making this call, send hello RabbitMQ, and ideally we should also receive this here. So yeah, you can see, as you can see, it is also receiving the message here. So the curl script is calling the sender function, and RabbitMQ sender function is passing a message which is going via RabbitMQ and going to the RabbitMQ receiver, right? And so this is working now. We should be able to see this in our SigNoz setup. So let's say if we are receiving data from RabbitMQ receiver, generally it takes some time, like not more than 30 seconds. Yeah, so as you can see, we are receiving data from RabbitMQ's receiver. We should similarly have been receiving data from RabbitMQ sender. And yes, as you can see here, we are able to see both the application here with the latencies we are seeing, operations per second. And yeah, let's just try to see some of the charts here because we have just started this application. You can see calls being made, some of the APIs being called. There's no errors as of now, and there's no external metrics here, so that's fine. What we'll do is we'll go to the traces explorer. As you can see, there are two functions, two services which we have. Both have been sending us data, and this is the last 6 hours, and this is just restarted receiving traces now. So if you want, you can just click on this, and as you can see here, you can see the complete flame graph here. A post request is being made by the sender. It goes through the middleware for this Node.js, and then finally here you can see the hello call being made by the sender function, and at this point the function is being sent, and this is the receiver where it's being received, right? So you can see a complete trace on when was it actually sent and when was it actually received by the receiver, right? So this is very interesting. You are able to see the complete trace graph of what's happening here, where it is taking time, and essentially this is the place where you are spending time on the RabbitMQ, right? So one of the things which is interesting, at least to me, is to understand what happens if this changes, right? So how much time is this taking from the query being sent from to RabbitMQ, the message being sent to RabbitMQ to message being received by the RabbitMQ receiver, not RabbitMQ receiver, but the application finally. So basically, this is the time which is being used in the receiver. So one of the powers here of SigNoz is you can create dashboards, which does exactly this. So here I have created a dashboard which measures, let's see. Yeah, so this is just one application point, but let's see. So this is what I wanted to show you. So if you see here, this is a ClickHouse query where we are capturing the start time for this sender function and the start time of this receiver function, and then we are capturing the time between these two. So it's essentially not exactly the time between these two, but like still it'll give you a sense on like how much time is that being taken, and this is a sample query or like what you can do with complex ClickHouse queries. So what here we have done is we have got data from two services and created a query which, as you can see, right? So we have created a query, if you like, which finds the time taken between the last span from the sender application and the corresponding span in the receiver application, right? So I think this is very powerful. You can find the time taken between RabbitMQ message between the producer and the consumer function, and this is something which is, I think, is very interesting to monitor and be able to see, right? And yeah, this is possible because you can write very powerful ClickHouse queries on SigNoz. So essentially, what we are doing, we are filtering for a particular service and for a particular span name, and just trying to find what is the time interval between them, and aggregating for each 1 minute. And what value you see is the average uh, time taken between these two spans in a single minute. Right? So for each minute, we plot this graph. So this is what you can see, and this time should change, I think. So you'll be seeing time difference between this and when it was received here. So this is the time difference which you are capturing, right? And also there's like bunch of metadata here. You can see the messaging operations which is processed, and which is the service name, what is the queue, what is the routing key, which is hello, and let's see, it's running on localhost. So a bunch of information here, right? I think let's do the next thing, which is what we want to do is also use this RabbitMQ receiver. So if you are not aware, OpenTelemetry also provides something called receivers, which are nothing but gets data from different formats. And like there are a bunch of databases which are being supported, or a bunch of data sources. We are interested in RabbitMQ receiver here. So what we'll do is just go to the RabbitMQ receiver. Currently, it only supports metrics at a data signal which it sends. So we will send that. And this is the example configuration. And this shows some of the data which is available. So some of the things which will be available to you are queue name. So these are some of the resource attributes, which is things which is passed with every metric. These are the metrics which are actually available. So the number of consumers, the number of messages delivered to consumers, the number of messages published to queue, number of messages acknowledged, and things like that, right? So let's go ahead and set up our OpenTelemetry collector. So just to take this further, we'll just go to OTel collector library. And what we have to do is you have to set up the config file where you have to add your receivers. So here I have added my RabbitMQ receiver. You have to add username and password, and then TS protocol here, because I'm just working with local database. It's insecure, but there is a way to secure this, providing the certificate keys, etc., to make sure the authentications is correct. And once you have set different receivers, what you have to do is to add it in the metrics pipeline. So if you think about OTel collector, it's essentially a data pipeline which has receivers, processors, and then exporters. And for each type of signal, you have to specify what is the pipeline you want to send that data through, right? So here we have configured receivers. So we are receiving data from RabbitMQ receiver, Prometheus receiver, and host metric receiver. Host metrics is nothing but it takes data from all the host metric related metrics like CPU users, memory users, and I'll show you a dashboard for that. And then it passes through these processors, and ultimately it's exporting in the OTLP format, which the authority backend, which is SigNoz here, understands, right? So this is the primary pipeline we are interested in for the metrics piece. So I have already configured the endpoints here for the SigNoz cloud end, which we have to send. And what we have to do is to is to just use this here. So I have already configured this in my hotel collector, and the hotel collector which I have run currently is using those receivers. So we are already getting all the RabbitMQ data here. So if you go to our website, to SigNoz dashboards, if you go to the dashboard sections, there's a RabbitMQ dashboard which you can see, and it has all the different type of messages and states of receivers which we have configured here. So the place where you can find this dashboard is just go to SigNoz and then dashboards, and we have a GitHub repo here. Let's see. Yeah, so this is the GitHub repo. You can just go ahead to this GitHub repo and then go to the RabbitMQ listen. You can just copy this from here. Let's try to create another dashboard, right? So you just copy this here, and then I will go to the dashboard section, say new dashboard, and then import JSON, and just fetch this file and load JSON, right? So this dashboard gets created automatically. It's a one-click import, and by default, you have all the metrics from the RabbitMQ receiver coming up here. As you can see, there are like 24,000 published messages. There's one consumer. There's no messages in the unacknowledged state. And then you can also see how many current messages are in ready state, how many messages are acknowledged, etc. Right? So let's do one thing. Let's try to send more data and see if this number actually increases, right? So is this thing actually working? So what we'll do is we'll just go to our file here and then again run our send request. Let's try to send more data this time. So let's say we want to send 10,000 messages in 30 seconds, right? And we'll go ahead and run this. And this should start sending RabbitMQ messages here. You can also see RabbitMQ being received. And now what we'll do is, so as this is sending, it will send around 10,000 messages in like 30 seconds. So ideally, this number should increase. So let's see. This is currently at around 20,000. We'll try to refresh it. This number has not changed till now. Let's see if the traces have started coming in. So yeah, so as you can see, the traces have started coming in. The trace count has increased. We also have a different trace explorer view, which can give you, if you just want to see the root nodes, you can see here. And you can see how much time is the root duration taking. It's around 29 to 30 milliseconds. You can again visit one of the root nodes and see where is the time being taken. If you know, this time has certainly increased a lot now compared to earlier. And I guess this is because of the high amount of volume being sent. So currently it's around 29 milliseconds for each post request. While let's say, while if you see earlier, it was around so if you go earlier, I'm just trying to look into what was the root traces spans right like earlier. So let's see. So see, this was around 14 to 13 millisecond, and then gradually it increased to 25 millisecond for each node. So obviously more data if you send, as you send more. So yeah, if you see, this was around 7 millisecond, and as we increase the scale to 10,000 messages per 30 seconds, this increased a lot, right? So let's see, I think we are seeing data coming in our, yeah. So now you see our published message count has increased. So it has gone from 24,000 to now around 32,000. This should ideally be around 34,000. Yeah. And yeah, now we are seeing that it's reached 34,000, which is the 10,000 messages we have configured to be sent in like 30 seconds. And yeah, this is how you can get more and more data about RabbitMQ. You can also get an understanding of, are your queues under stress? So you can see what is the message current count and filter it based on unacknowledged messages. This will give you an idea on like what's the delay messages are facing, and probably an indication of where to look further, right? So yeah, I think this is what I want to show. We saw how you can go from like a simple demo of applications sending messages via RabbitMQ, and then seeing the complete trace in the receiver. We also saw how you can create very custom dashboards using powerful ClickHouse queries and see the time difference between the two spans from the sender when it sends to the receiver where it has received. And then we also saw using the RabbitMQ receiver, you can get standard metrics. You can see standard metrics data about the RabbitMQ queue and get some more understanding of that. So yeah, that's all I wanted to share. Thanks for visiting, and have a great day.